How's it going, everyone? Euler Gonzalez here again, and today we're going to talk about is React Performance, which is a course taught by Steve Keeney, the head front-end engineer at Temporal, a durable execution platform which is behave pretty much like Kubernetes. So the goal of this course is that now we can write this React Performance applications, React components in the most performant way possible. And to do that, well, we need to first understand and eventually understand how React works behind the scenes. And now, then, how you can build a tool set to diagnose performance issue when it comes to rendering components and develop some best practice to actually tackle that. So that's the entire reason of this course and also this series of videos as a way to now improve my technical communication skills, be precise when I need to describe complex idea in React and make it meaningful for not only my college, new grads, new developers, but also for business people, right? The marketing people, the shareholders. I think this is something very, very important as an individual to improve that 5 points, right? Not only the analytical skills, which is how is your thought process, okay, but also is your technical communication. Is that can I implement your approach based on your explanations? And then, all right, are you able to follow is the best practice? Do you know the best practice? Do you know the trade-off of that? Also develop some soft skills. So for example, hey, are you empathic with yourself and with others? Do you have patience? And lastly but not least is the domain-specific knowledge that you need. In our case, with React and with JavaScript. So I really love about the power of JavaScript, especially as a way to help us to write this complex application that bring interactivity and how the language has evolved over time. So now with that huge or little introduction, the specific goal of this is to see, well, how can we learn how to structure our components to make sure that it performs as quickly as possible, learn how to memorize using built-in React components. We're also gonna see is that how you can now defer tasks or how you can now load code just when you need. Look at also is the concurring feature of React 18, okay? And also now take a look at the architecture of React 16 as a way to understand how do we get here, what are the benefits that this particular approach provide us in React, and then how can we use the React Dev tool, for example, like the profilers, to diagnostic performance issues. So this course is laid down in this, like this. So you got the introduction, React rendering, React reducing rendering, context, space, and transition. So far we went through the introduction, okay, as a way to describe how do we get here and the reason of this particular course, okay. And then we're gonna jump into the React rendering, and for that I'm gonna make a quick recap here from the React docs, especially by developing this storytelling, which is something that is important for me and for the audience and for the people that actually look at me, as a way to now make all of this complex topic meaningful to others and also to improve my technical communication. So we're gonna wade through this, okay? we're not going to dive too much into React compiler. The page will introduce to the new experimental React compiler and how to try out successfully. React compiler is a new experimental compiler that we have open source to get early feedback from the community and still have rough edge. It is not yet fully ready. Okay, it's not yet fully ready for production. So React compiler requires React 19 RC if you're unable to upgrade to React 19. But again, the idea of this is to actually look at this experimental feature that might be implemented in the future. But in any case, what we really care about this is that how we're going to, from the quick start, look at the particularly is the learn React here as a way to describe in the UI how now you can use this features and syntax that React provide you as a way to now allow you to render these UI elements, and how we need this when it comes to adding interactivity. We need to understand is a particular model, and that is how now React works behind the scenes, how actually React allows us to add this nice interactivity in our applications. Okay, so once we know how can we so once we know how React actually render those once we know how React works behind the scene, allows us to rendering all of these UIs, which they call this as state. Okay, so how now can we manage those states, all right, in a way that aligns to the React? And lastly is the escape hatches. Okay, so now these more advanced topics or specific use cases like this, which are indeed quite important. Okay, so for example, how can we now render UI elements that happens outside of the normal execution, that happen outside of a function? Okay, and I think this is quite interesting as a way to now write it down, improve our technical communications and that kind of thing. So once we are able to describe that, okay, then we're gonna now look at from the developer perspective, and thanks to Steve, as a way to say, okay, this is now all the theory. Now you know how you can create and describe how do we get here, which is great. All right, what are the things that we're gonna look in the field, right? The real job. And that's why we're gonna now describe is how Steve actually give us is some recommendations as a way to all of these concepts, shrink it, make it core, make it short, the TLDR. Then look at how can we now diagnose this kind of issues. I think this is quite, oh my God, today it'll be a very interesting day. Today it'll be a very, very interesting day. So rendering cycles here, because at the end of the we react, okay? So first thing first, we'll look at on the React rendering, specifically what are these sets of tools that allow us to diagnose this kind of performance issues, which is great, okay? So how can this allow us to have this? All right. Yeah, makes sense. Totally sense. And that is, well, first look at the React life site is productions. That's the way how you can start it. So do you have this bundle on production, not on development? Okay. Then you started to look now at the component hierarchy. Okay, as a way to now then use the React Dev tools that allow you to inspect a little bit more which one of those components actually get rendered. So even though that you are using is the dev tool as a way to inspect that, and there's some quite interesting questions. So for example, when it's React Profiler is not enough, okay, and it is very it's highly specific when you write your components. The TLDR focus your attention and then your component do what it's supposed to do, okay. And if you are sure that it does what it does, that it need to, all right, so then you can now take a look at other places. For example, the browser profiler. But the TLDR is that focus your attention on what you're doing. There is another question here, like how much overheat does the benchmark itself? And again, here it will base on percentage rather than absolute numbers. Why is that? Because with percentage there are much more useful metrics as a way to say, hey, in the last sprint we got is 60% of downside, but now we got is 50, 10, 11% less, right? You say, oh, all right, that's a good indicator of now how you can diagnose the performance here. So, but before going into that, we need to really understand what is what React does, right? Because usually there is a lot of people actually that are starting in this industry when they're starting to know how to write at least simple UIs, which is, after all, that's what now React allows you to do. Okay, you got an state that you want to generate view out of this, all right, and it makes a lot of sense as I move on here in the course. But the idea here is that all of those people that are getting here, they actually don't understand is what is the end goal of React. One, not only to allow to write is UI, but also how this works. And why this is important, because if you're going to provide this service, okay, is relevant to know how that works, and especially if you want to provide your services to companies, and whether it's on real estate, e-commerce, the military, healthcare, since the idea is that whatever industry you're going to show or you're going to offer your service, it is important to understand that at the end of the day, how React works. And we're going to walk through this thing or through the Learn React docs as a way to describe and to improve our technical communication here. So, because after all, React what allows is to create this UI, okay, user interface on the browsers. We need to first look at how can we describe, how can we write this UI, okay? And that is, well, how to write your first React components, when and how to create multiple, this is something here, importing and exporting here. So when and how to create multi-component files, how to add markup to JavaScript with JSX, how to use curly brackets in JSX to access JavaScript functionality from your components, how to configure components with props, okay, which is now by passing is the props as it is, and then down there you're going to receive is these props like that. Then how to render multiple components at a time, which is conditional how to conditionally render components, how to render multiple components at a time, which is rendering less. Okay, how to avoid confusing bug by keeping components pure, because now we are using is this, and why understanding the UI tree is useful. So first things first is we're talking about React. Okay, so React allows us to build this user interface, and the way how can we describe that, okay, is by looking at its core functionality, which is initially as a React component, as a React.create element. Okay, and because this is quite verbose and lengthy, we prefer to use this JSX syntax. That what allows is to now provide is a funny, weird way, but actually useful, to now interact with the DOM. And so by interacting with the DOM and describing its interactivity. So it's describing interactivity on JavaScript with the DOM. I think that's great, because now when we look at how can we define our JSX components and how it's important to look at those components as a functions, okay, as a way to guarantee that any time React call this component, it runs only once. So this has a predictable state, okay. And then we look at how can we render this conditional elements, okay, using the if or the ternary operator, as well as how can we render list of components, okay. And now how by understanding is the UI or the render tree, as well as the dependency tree, it will lay out our foundations to what comes next, all right, which is the performance. So after all, the way how now all of these elements are added is in a tree-like data structure, which is from the computer science. We're not going to talk about that, but these data structures allow us a nice way, a compelling way to store data and interact with that in the most fast possible way. So we have now arrays, okay, collection of elements, okay, and we start from the beginning, and then we iterate through that. So we have arrays, we have now maps or hash tables, okay, so dictionaries, okay. You have now a key, and it is description, and it is value, okay. It's another way of how can we organize the data. When we have now is heaps, or prefer to call stack, all right, stacks and queues, all right, where now this particular way of allocating data or putting elements here, it allows to interact with them. For example, in the case of stacks, we're gonna have is all of these elements putting one after another and the another and the another and the another, okay, and we're going to interact it with the first element here. And you may wonder, why in the F do we have all of this stuff, these things called data structure? Again, each one of them allow us to store or retrieve things. Why do we need to care about store or retrieve things? For example, right now you might is to look at your phone and you want to download something. So you want to download several apps. Let's say TikTok, you shouldn't download that, but in the case TikTok, Instagram, Facebook, video editing, blah blah blah, you know, and you have all of these things scattered, and you want to now find a way to organize that. Why do you want to do that? Because you want to save time. You want to, when you get to your cell phone, it's like, okay, you unlock your cell phone and you know how to find everything there. It's like going to the kitchen. It's like that you know where all of these are, where all of these things are there. So you don't have to ask yourself, it's like, hey, where is the spoon? Perhaps sometimes if you live with your family or you live in some residency, it's quite hard, it's quite challenging to do that. So that's one of the reasons why a lot of people actually say, hey, no, I'm gonna get my own set of um, my own set of knife, spoons, you know. So yeah, I don't want to actually dedicate time to that. As the reason why we have this data structure as a way to now, anytime we need to organize our data, organize our data, we know how can we interact with them as a way to get the data fast. That's what we have is stacks. What we have is queues. Okay, pretty much like you went to a supermarket or to any queue here in the cafe or restaurant. It's like you do a long queue. Usually you do that, and you say, okay, I don't want to do this. You know, I I appreciate my time vastly. I don't want to be here. Not right now. I would like to get in, but and the way how now you can solve that is perhaps next schedule, you know, organize. You schedule that to say, okay, instead of going this, I'm going to now, instead of doing this, I'm going to now came here later. Okay, so this is the reason why I'm describing is all of these data structures. Okay, and it is quite again, it is the way how you now write all of this data structure so the machine can understand can be quite complex, but at the end of the day, you want is this. You know, always remember the goal, and that is, okay, I'm writing this that it might look like a modern art, okay, but what is the end goal of this modern art? In this case, it's like, hey, how can I organize? How can I tell this computer to organize data for me? And it can do that very fast. Okay, so this is data structure. This is now how the render tree, what it only matters, or what it only cares is that React used the render tree as a way to keep track is all of these components, all of this UI, as a way to, hey, yeah, we're going to render this component. All right, good so far. And the other is the dependency tree, which says, hey, we're going to add now functionality to each one of those UI elements with components, and we want to do that in the most efficient way possible. Okay, we want to reuse some of those models. But this is the two concepts that stayed here in the React. If you don't believe me, for example, you can take a look at this and see how React sees component structures, okay? How React can now keep track of these component structures, what a render tree is, what is useful, and what a model dependency tree and what is useful, right? Yeah, the render tree. The render tree. Except identify this category of components are useful for understanding data flow and performance. So, exactly, render tree. So, understanding the render tree, allow us to know how data flow and optimization works. Okay. Exactly. Understanding the render tree. Exactly. Or understanding the render tree. Identify this category and components are useful for understanding data flow and performance in your app. Exactly. So understanding the render tree allows us to know data flow and how optimizations works. Okay. And when it comes now to the model tree, okay. So as your app grows, often the bundle size does too. Large bundle sizes are expensive for a client to download and run, which is now when it comes to the code splitting. Okay. So large bundle size can delay the time for your UI to get raw. Getting a sense of your app's dependency may help with debugging this issue. But the dependency tree is useful to determine what models are necessary to run your React app. Okay? So understanding the render tree allows you to know is the data structure and how optimizations work. And understanding the exact. And I think this is the core of this React. And then understanding is the dependency tree. Allow us to know which code needs to what models are necessary to run your React app. When building a React for production, there is a typical build step that will bundle all the necessary JavaScript to ship to the client. The tool responsible for this is called the bundler, where it can be a Webpack, Vite, you name it. And bundlers will use the dependency tree to determine what models should be included. But the whole point to do this is that understanding the dependency tree allows to know which models are necessary, or which pieces of code are necessary to run our app, to run our React app. Okay. Because this usually involves is the production step. Okay, because this involve a build step to launch your app ready for production. Okay. Exactly. This will be used by the dependency tree. What model should be included? As your app grows, often the bundle size does. So large bundle sizes are expensive for clients to download and run. So because this involves a build step to launch your app ready for production. So as your because it's ready to production, it uses a model bundler, okay, like Webpack, Vite, or any other, okay, to do that. And as our app grows, and as our app grows, it is expensive to send JavaScript code But yeah, as our apps grow, it is expensive to send uh, big, big bundles of JavaScript code to the client. Okay, that's one of the reasons what is important to understand is this as a way to create this storytelling, as a way to create this storytelling here. So now that we know that, all right. So now that we know how can we describe these React components, okay? And by looking is at how GSX works, what is before GSX, what GSX allow us is to actually now add interactivity to our markup, to our HTML, and then how can we now then is showing conditional rendering. How can we render less of elements or components? How also can now how also can now is write our applications using, instead of a class, a function, as a way to be JavaScript friendly, since functions in JavaScript are first class citizens. It has now it allows you to run them as well as to add some property. After all, everything in JavaScript is an object. So in the case of functions, it's a special type of object, all right, that you can run. And also it has a property called prototype that allow you to now is define all of the functionality that you want to. And by using it, for example, new keywords, the new keywords, when you run a function constructors, it automates the process of linking the prototype. In other words, it's automate the process of creating an object with these properties, and an object is just how can we now organize our data with the data and its relevant functionality. Is an object-oriented programming. Okay, perhaps you lost me quite a while ago, but the idea of making this quick recap is as a way to now, by explaining you this, is that you can see how all of these are connected. And that's exactly the reason why improving your technical communications is so vastly, as well as your soft skill, as a way to say, all right, everything that I learned, where it comes from, can I explain that in the most precise way possible? Okay, so now back to what we care, the JavaScript. Okay, so because of that, all right, and at the end of the day, when we for example, we're describing here is the reason of why we're looking is as or what is important to create your React components as functional components, okay, as a function. All right, now we're gonna see is that how important is also to understand is this concept of function or pure functions, which means is that giving a particular input, you will always gonna return is the same output. That's a very interesting topic, because at the end of the day, you want this predictability, especially if you're going to manage things. If you have kids, or if you have a pet, okay, you know how hard, or if you have a cousin or a brother or a sister, you know how hard it is to control that. You don't want that, but sometimes they need to behave, all right, especially if this is 1 a.m. 1 a.m. at some dangerous places, okay, 1 a.m. and California streets, or California, Chicago streets, 1 a.m. New York, Buenos Aires, Venezuela, Medellin. There's some places that you should behave accordingly. And that's one of the reasons why, in this context, it's important to understand that this functional approach, its understanding is why we are writing is functional. But in any case, move on. Because now that we know that, now that we understand that, okay, now it is time to look at how can we add interactivity. Because at the end of the day, it's like you just writing his single HTML period. It's like what would be the difference to write single HTML if we don't having the ability to add functionality to this. So by adding the functionality here, okay, which is first how you can now add in or how you can communicate is the JavaScript side to the HTML using the handlers, okay, as a way to respond to them, which is so far so good. Passing a function correct, calling a function incorrect. Exactly, it's incorrect completely. This difference is subtle. In this first example, the handle click function is passed as an on-click event handler. This tell React to remember it and only call your function when the user clicks the button. In the second example, we are now executing that. Fires the function immediately during rendering without any clicks. This is because JavaScript inside of JSX execute right away. So this is passing a functions correctly, like so. In this case, an arrow function, and calling a function is incorrect, like this. Like no. Passing inline code like this won't fire on click. It fires every time the component render. If you want to define your event handler is a handler wrapped in an arrow function. Why do we have this arrow function? What function are? Which is arrow functions are just a way of how you can fix, or it's just a way of how you can now give more deterministic behavior for the this and the scope, especially with the this. Why is that? Because after all, JavaScript is a dynamic prototype language. It's a dynamic prototype language. It's a weakly type dynamic language, which means that you can reassign variables. All right, it's like you say, hey, let's go out to buy some coffee, and then I change your signal because I can and tell you, hey, no, I won't be able. Now follow me to my come with me to my car quickly. It's like no, sorry, I need to go back to my desk because I forgot the keys. It's like no, oh sorry, I had the key here. It's like, man, woman, sir, lady, please be serious. And it's like, be serious about it. And that's one of the weakly type, okay? And the dynamic nature is that because this is a script language, it's not compiled, all of this instruction is happening at runtime. All of the things that I'm telling you, it happened in the moment. Which, if something goes wrong with one of those statements, your app crashes. So you don't have now this deterministic behavior that, for example, a programming language like C++, okay? I'm not sure if Ruby is a script language as well. Okay. But I think this is a script language. Yeah, it's an interpreter. So no, not at all. So Java, or in fact, let me actually put it static, static and strongly type. Strong and weakly type. But I want to take a look at the static and strongly type language. No, I want to take a look now at exactly like this. Yep. So for example, static strongly types like C#, I really would like to love to program in C#. Okay. But like C, oh, really? Really? Okay. Interesting. And I really love Stream. Yeah, I really love C# because it's a strongly typed language. You know, because it's a strongly typed, because it's an static, which means that you're not evaluating line after line by line. You just now first generate those instructions, okay, and then at build time, you see if there is an error before you're going to deploy that. And it is strongly typed because it tells you, hey, give me only one instruction, you know, this is it, deal with it, you don't like it, your own problem, your problem. So C#, interesting. C# in Java. Oh. All right. So, yep, that's right. This is it. Experimenting in the lab. Oh, okay. It's currently available in the US. That doesn't matter. Yep. Well, anyway. Okay. So, but again, yeah, the idea of now looking at how can we now add interactive, or how can we interact with the from JavaScript to the HTML, okay, especially by by interacting with the event listener. The way how you do that with plain JavaScript, or plain JavaScript, plain yeah, The way how you do in plain JavaScript is by you say, hey, let me now access to the global object called document that we contain is all of these elements, all right? And then now, when you listen an event listener like click, okay, all right, you're gonna now add this handler. All right. So, and because the nature of how can now GSX work is by passing is the function definition, not the run here. And that's interesting because now, all right, as we started to do here, it's like, hey, this is now how you're going to handle that. And you're going to return this at the bottom and that kind of thing. So you have now several buttons here to show. You have upload button, and they have the toolbar, which is going to show you is these different components. Play button movie here, and then upload button. So, hey, place Kiki delivery service, and upload image, uploading. You know, naming event handler props like this. Okay, naming event handlers here. So pretty much like the way of how you do that using that on. Okay. And on click, like so. And then you got it, right? So, and how you can now stop the propagation, which is something that is particularly to the browser. So when you define is, for example, event on that, the first time it's trying to call that, it's going to select that element. Following is a tree data structure. It's going to look at it. It's going to iterate to find that path, and then it's going to say, all right, now that I get this, it is time for me to actually run this function. But I'm gonna run these functions on any elements that actually have that. All right. This is now the event propagation. So if you want to stop that, which is something that happened on the browser, if you want to stop that, you should use the event stop propagation. So all of these things in capture phase event. So in rare case, you might need to catch all events on child elements, even if they stop propagating. For example, because of this. And they talk about here is the capture phase event as a way to, now that you know, now that you want to interact is this, bubbling and capturing, okay, which is a behavior by default, okay, on that. So it will now going down to that as a way to capture that event. Hey, I'm gonna capture that event by looking down to the 3, okay, and then if there are any other elements that actually are running that function, I'm gonna call them, I'm gonna call them, I'm gonna call them, I'm gonna call them. So for example here, this is now event bubbling. So if you click here, the first time the browser say, hey, let me now capture this event, I'm gonna capture this event, but there also, and when I bubble in that, when I run those functions, I'm going to also is this function that you run, this handler here, I'm going to bubble up. I'm going to hold it recursively if I found that along the way. This is interesting. This is interesting. Almost all event bubbles. The key word in this phrase is almost. For instead, a focus event does not bubble. Exactly. So not all events bubbles. And that to me is quite interesting because it's like, why do we have that? You know, why do we have this event bubbling stuff? Why do we have this event bubbling stuff? Exactly. Most deeply nested element. Exactly. To event the target. And that to me is quite interesting because this is a script. Exactly. This is now how you can interact with the elements. Alright. This is truly how you can interact with this element. As a way to say, hey, I want you to now from JavaScript interact with this element thanks to the global object, that document that now allow me to say, hey, this object document that represent is all of these HTML elements. Okay, what do you want to do with it? What do you want to do? What do you want to do? The DOM. You got the DOM API. It's like, what do you want to do? What do you want to do here? You know? What do you want to do here? Okay, so connect the web page to script or programming language. So what do you want to do? What do you want to do? Okay, and I got several interface. Okay, again, this is also following is the solid principle. Single responsibility, open and open to modifications, open to extensions, close to modifications. The least substitution is that a subclass object must or should replace the parent class. The inversion dependency, the interface segregation as a way to say, hey, instead of having a huge gigantic object, okay, let's go to create now several specific interface that clients can consume, that users can consume. For example, like interface. Okay, and you got all of this. So you got now, hi, this is the element, hey, this is the event target. You have all of this interface for that. Okay. This is all the interface that you can have. All right. And document, you know, this is at all the interface for that. Okay. So document for that. So once you now access to the document, is to create a new document object. In this case, this interface also inherits from the nodes and event interface, which means is that it can have access to the node and event target interface as it is. Exactly. Like so. And that's quite interesting, this kind of review here. Why is that? Because now it allows you to say, okay, what we have to do and how can we describe this? Introduction to the DOM is a way to say this. Using the query selector, okay. If you're gonna get all of them, accessing the DOM, for example, like this, exactly, through the document or window objects. Okay, you can immediately begin using the API for the document or window objects to manipulate the document itself in any of the various elements in the web and descending elements of the document. Your DOM programming may be sometimes as simple as the following, like this. Hey, when there is an event here, because after all, the DOM is actually have it exposes this interactivity. All right, what you wanna do? You know, it's accessing to the DOM. It is generally not recommended to mix the structure on the page, reading in HTML, and manipulating DOM, reading in JavaScript. The JavaScript part will be grouped together here and separate on the HTML. Exactly, like plain JavaScript. Fundamental data types like document. We're going to remember the terms of a document type like this. So you got the document reference for this. An interface and objects, okay? It's like, okay, now this is the DOM, this is the representation that have, instead of giving you the entire object, we're going to create now is this interface segregation, that you can now consume that are more specific for that. So interface and objects like this. So document get element by ID, table, we get now the table, okay? And this document get element by ID is a fairly, this is part of the DOM, okay? You say, hey, this is the instance property. Okay, all of the instance property like that. As you can see, this is a valid. For example, class name is a valid here. And this is now the methods, instance method, and static methods. So it makes a lot of sense. You know, it makes a lot of sense. As well as the event that we can listen to. Hey, this is a scroll, the scroll end, visibility change, and inherit from this. Copy, cut. Interesting. Interesting. Add an event listener to copy. Okay. And then on copy, okay, how this is even trigger. Oh, okay, let's actually take an example of this. Document on copy. But this is on copy. Okay, if you detect the copy, all right, that's quite interesting. That's quite interesting. So for example, if you detect now the copy here, okay, let me see if you have here. So for example, if you detect now a copy here, say on copy here, I want you to now is doing this. Alert, you are copying, you are copying, and show the event. Copy, and that kind of thing, like so. So if you are copying, example, hey, here, input. So if you are copy, exactly, but it's only done copy, and that's lovely. At event here, but it's detected is at the DOM level. Hey, someone actually triggered this? Do that. So on copy, interesting, very, very interesting, very, very interesting. Oh my God. Okay, Again, that's not the end. That's not what we signed for. That's not the goal of today's video. Just a way of how can we describe this kind of event, okay, this kind of thing, as a way to say, all right, how can we combine all of these different contexts and content, and from there you say, all right, it'll makes a lot of sense. It'll makes a lot of sense. Accessing the DOM and that kind of thing. All right. Okay. Cool. Cool. So the reason of looking now this is just as a way of how introduction to events is the JavaScript info. But what if we want to, for example, say now events, right? Event. Okay, for example, web API, the event, okay, the event, like this. Okay, so how can we make this the event? But it doesn't tell me is that introduction to event, UI event, mouse event, moving the mouse, drag and drop, mouse event, pointer event, and here keyboard scrolling. I'm not sure who made this. Oh, in 2007. Holy moly. In Russia. Holy moly. Interesting. Interesting. Holy moly. That's quite interesting. Okay. Okay. Exactly. During pandemic, everyone is there. That's quite interesting. Interesting. Very, 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 very interesting. Very, very interesting. Very, very interesting. Okay. Document and resource loading. Script async and defer. This is sibling chapters. That's quite interesting. An introduction to this, code quality, Ninja code, Brevity is the soul of the wit. Show your love. Side effect everywhere. But again, this is just to solve their particular problem. Okay, 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 okay. Cool, 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 cool. Awesome. So, now with this, all right. With this particular example here, so we do, hey, how can we copy? Hey, how can we do this? And then another, and that kind of thing. Okay. As we look now, how can we add interactivity to our React components as a way to look at how can we define our functions, our handlers, that we can now bind them to the JavaScript listener on our HTML. Okay, and how by passing is this reference here, not running them, and if you want, for example, pass some JavaScript functions, you use this an arrow function, all right. But event handlers are the best place for side effects. And unlike rendering functions, event handlers don't need to be pure. So it's a great place to change something. For example, like this. However, in order to change some information, you first need to wait to store that. And in React, this is done by using this state component. So now that we look at how can we connect interactivity from the JSX to the HTML using is the JSX syntax, okay, then that's useful. Okay, we're starting to now adding interactivity, but when we need to add data to that, now is when we look at the state, a components memory, and how this components memory, like this, okay, is just a place of how can we store this data in a persistent way throughout entire season, okay, using closures, which is now a nice little JavaScript bonus feature that when you return a function from another function, it now allows you to access to the lexical outer scope, to the lexical environment outer scope from the inner scope, as a way to now not only provide you access, but store them persistently, and store them persistently in memory during that season. So that's quite interesting, because all of this is starting to slowly make sense. And again, it is not your fault, the word, it is what it is, but it's your responsibility to get it. Lexical scoping. Okay. Then you get is this function init name, blah 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 blah. And init create local variable here, but we are not returning anything. So as a function here is just like that, right? So a closure is a combination of a function bundle together enclosed with reference to its surrounding state lexical. In other words, a closure gives you access to an outer function scope from the inner function. In JavaScript, closures are created every time a function is created at function creation time. So what they don't tell you is that this is persistent. Closures are useful because they let you associate data with a function that operates on that data. This is obviously parallel to the object-oriented programming, where objects allow you to associate the data with it is one or more methods. Consequently, you can use closures anywhere you might normally use an object with only a single method. Situations where you might want to do this are particularly common on the web. Much of the code written in JavaScript code is event-based. You define some behavior and then attach it to the events that is triggered by the user. The code is attached as a callback for that. So for instance, suppose we want to add a button like this, but such interactivity, the text size button can change the font size. So if you have now for all of this, okay, you can attach them to buttons as demonstrated in the following code, like this. So you are creating a closure for that. Hey, I'm going to store this persistent, emulated private, but it doesn't tell you that this. It doesn't tell you that this, okay? Yeah, it doesn't tell you that using closure is a way. In this way, provides benefits that are normally associated with object-oriented programming, in particular, data hiding and encapsulation. Closure scope change, local on scope, enclosing scope, and global scope. Every closure has 3 scopes. A common mistake is not realizing that in the case where the outer function is in itself a nested function, access to the outer function scope, including the enclosing scope and other functions, effectively creating a change of function scope. To demonstrate, consider the example like this. You can also write without anonymous function. So you are now accessing to that. It can be more interesting. Oh, and this is per model as well. Closures over models. Because you're returning as a function, it's actually enclosing that over models. Closures can close over imported values as well, which are regardless as life binding. Because when the original value changes, the imported one changes accordingly. For example, here, close over an import life binding. Okay, you are storing that in a persistent way. Creating closures in loop are common mistakes. Oh, because after all, this is a function. So on focus is a function, it's an event listener. You're now hosting that help text, yeah, hosting, and then when you're gonna get that element, you say on focus, say get element by ID, exactly here, and the methods like so. In return is an element, okay, that this element can have, okay, can have all of its property and it is event associated. Okay. Okay, instance methods. Event exactly like on focus. So event properties. This interface also inherit property from its parent, UI event and the event. But this focus, okay. The second parameter is an arrow, exactly. This add event listener, for example, like this, would get element by ID, and then on focus, exactly, because on focus, in fact, global event handlers, event handling code. But this is okay. This is event. When you listen this, okay, on focus, you're gonna this. I want you to run this. But you are associating is that to this. Exactly, you are associating is that to this. You are associating is that with this. But the item ID, item.id is defined here, so you have access. But on focus, you're going to attach this function. But it's because you are returning is that function. The loop cycle through this definition. Hooking up another. Okay, the loop cycle hook from this definition. So document the get element by ID on focus and function that. If you try this cow out, you will see that doesn't work as expected. No matter what field you focus on, the message about your age will be displayed. Because it's like appending is that, but not for this element. But not for this element. In fact, is for the reason for this is that the function assigned on focus form closures. It's because you're returning this. So document get element by ID. Okay, so what is doing here? You are now evaluating as a statement here, and you say, hey, this property, okay, will be a function here. But this property here, the on focus, okay. Now show help here. It's saying I'm gonna call this, and I'm gonna get that element by the help. Okay. And the concept of text of content will be help. The reason for this is that the function assignment focus form a closure. They consist of the function definition and the capture environment from the set help functions code. 3 closure has been created by the loop. It's like for some reason you here are creating you are now running, okay, on focus. It's because you are a function here? You are running a function? But this is on focus. It's to create another function here. And when you're creating here, you're saying it's not the value of this, okay, will be whatever is on, it's creating a closure around the value of this. What is this? Document get element by ID. You get that value and then you, now this is an element. Okay? This is now an element. Okay? Element on focus. La propiedad on focus return this. The focus event fires when an element has received focus. This event is not cancelable or not and does not bubble. This event property here anyway. Again, this is quite interesting, but we in fact inheriting this from the UI event, focus event. Focus relative target and event that target. Why this is important? Okay, especially when you are doing is this kind of thing. This is not quite relevant to our case, okay? But again, once we're able to know this closure stuff, okay, that at the end of the day is what now React is using as a way to keep track the state, okay, our data. When creating a new object method should normally be associated to the object prototype rather than define its own object construction. However, redefining the prototype is not recommended. The following example instead appends to the existing prototype. In the two previous examples, the inherited property can be shared by all of property here. But again, claw. Are closure persistent? It's a persistent local variable scope. But it's interesting that it doesn't tell you that. Exactly. A closure is a persistent local variable scope, such as JavaScript, Swift, and Ruby. Mm, that's quite interesting. But again, it doesn't tell you that. Now, you know what? I already. Let me actually take a look now at the documentation. Yeah, like this. Exactly. Like closures here. Closures and environments were borrowed from Scheme. Self-inspired JavaScript prototypal inheritance. Self-inspired JavaScript prototypal inheritance. JavaScript syntax is largely based on Java. AWAK influenced JavaScript functions, including the keyword function. JavaScript strings, arrays, and regular expressions take cue from Perl. HyperTalk inspired event handling via onClick in web browser. And with EX and ECMAScript 6, the new influence came to the language. Generators were borrowed from Python. And oh my god. Okay. Okay. Let's get into this, my friends. Let's get into this, my friend. Let's get into this so you can see actually why am I looking, by the way. But I want to open that is, yeah, I want to open now this on here. I want to open this here. I want to open this here, exactly. Like close, and I think this is the first step, right? By reading actually is a documentation from this author, Axel Rausmeyer. Shout out to him, bro. Jesus. Shout out to him. Totally. Shout out to him. Oh, nigga. Alright.
What would still be nice to have. And what I'll be talking about is my opinion. I'll talk about the DC39 has to have had a look at your proposal. So you have to pursue two kinds of values. On one hand, you have primitive values, and these are compared would be to have a new kind of class, or to just tag a class as, or rarely, I offhand I can't come up with a use case. 3 bits plus a sign for integers, And if you go beyond base 2 floating point numbers, and then you have the classic here, type of null is the famous one, that null is the type of things that null is an object, which
and partial application.
So what we're doing down here is we're global variables. So starting a worker, JavaScript at the moment has the most deficiencies, or well, deficiency is not the right word. Cosmetic thing that I would like to use is we use the namespace object math, then doing to an array before you can process it further. And if you had
okay,
it's more lightweight, it works directly with object and arrays, and but processes them in between. You just get easy to use, and yet if you have nested expressions, they look as nice as currency and a bigger standard library. And if you want to download the slides, this is the QR code for it. This is the URL where you can find the slides. You can read, so this blog post is a transcription, and my JavaScript books are free to read online. Thank you.
Oh my god. Okay. Okay. That's great. So shout out to Axel Rush Mayer. Duality. And the duality is like that. It's like, okay, that makes a lot of sense. Why am I looking at this? As a way to understand where all of this comes from. Exploring the JS, deep JavaScript theory and techniques. Okay. Working with data. Protecting objects from being changed. Subclassing a promise-based constructor optional. Copying instance of class. Immutable wrap object collections. Regular expressions look around assertions. Exporting promise by implementing the exploring promises by implementing the meta-programming with proxies, revealing construction pattern, and this exploding promise by then okay. Anyway, because the idea here is to actually take a quick recap of how do we get here as a way to understand this a little bit. Book and supplementary materials, and especially when we talk about is the the closures, right? Pros and cons of JavaScript. Exactly, the natures of JavaScript. Interesting. So generators were borrowed from Python. The syntax of arrow function came from CoffeeSprint. C++ contributed the keyword cons. The structuring was inspired by list structuring binding. Template literate came from the E language, where they are called quasi-literals. Interesting. So I know where generators are coming from, and iterators. Okay, okay, okay. Again, this goes beyond the scope of this, but with the whole point of this, we wouldn't just want to ask a particular question to this, which is where closures are coming from. Closures. Closures. Yeah, closures. No, that's right. Exactly. Closures. Bound variables and free variables. What is a closure? A closure is a function plus a connection to the variable that exists and its birthplace. Static scoping is supported via closures in JavaScript. Therefore, every function is a closure. Static scoping, and when you say static, it's like, I got this. Use case for closures. For a starter, they are simply an implementation of a static scoping. Static scoping. As such, they provide context data for fallbacks. Context static scoping. Strictly speaking, in practice, most language static scoping. Lexical scope, also called static scope. Name resolution depend on the location in the source of the code, and the lexical context, also called static content, which is defined by the program where the name variable is functioning construct. On program state. But it is interesting because even though here static scoping is supported via closures, therefore every function is a closure. Static scoping. Okay. It means that it's lexical scope. It means that it matters where it was written. It's supported via closures. In JavaScript, therefore, every function is a closure. Okay. And provide the values for the free variables of the function. Even though it escaped its scope. But it is pretty fucked up because none of them explain that. I mean, yeah, they explain what closures are. Okay, they explain what closures are. But it doesn't tell you, okay, it doesn't tell you this is persistent. It doesn't tell you that it persists. Because even though they know, they don't know how, they don't know if that actually persists. Are closures, is closure in JavaScript persistent? Jesus. Lifetime of a closure here. It usually happens when there are no more reference pointed to them. You can manually destroy them, but if you know what is referring, you could delete the reference value, and it should trigger the garbage collection. Okay. So you have to make them and implementing callback function with persistent state. But this is when you can have access to that. Function location. Back then. But now you can no longer have access to that. You have to look at how that works. Anyway, but the idea here is that by looking now at the closures here, and understand that first, when we're describing your or UI, we mentioned is that how you can do that using the GSX, and then how now you can is rendering elements with a condition, listing collections of elements or components, and how you can now is using is the arrow function as a way to create this pure component, as a way to get at deterministic behavior. Anytime React look at this, it will render this given a particular condition, okay, a logic that you define in your GSX, and as a way to understand how now this actually and how the UI and as a way to know how React keep tracks of all of these components that you're creating, we look at the render tree, which allows you to understand is how now data allows you to understand is data flow, and how can we optimize our performance. Okay, and in the dependency tree, as a way to now which code do we need this to load, especially as our application grows and grows and grows. So it is expensive to send that to the client as our application grows and grows. So by understanding these two models, then we look at how can we add now interactivity, and that is by looking at how you can connect your JavaScript code to the HTML, okay, using is the handlers, which is so far so good, no problem. And by looking is at how can we now passing functions to the handlers on our HTML, okay, as a way to trigger now this event, starting to add functionality, the side effects. Now, not only we need also look at not only run this function or establish this link between the functionality, as well as how can we now show data. And for that, we have now the components memory state, a components memory, which is using its closure as a way to now React keep track of which state, which data change. So here we look at how can we add a state to our variable using the use state. What pair of values state hooks returned. So we to understand what this state return. Okay, so we to now provide interactivity and remember things. Okay, the current input value, the current input email, the shopping cart. In React, this kind of component-specific memory is called state. Okay, and how to add more than one state variable, and why state is called local. Interesting. Hooks functions starting use with use and can be only called at the top level of your component, your own hooks. Okay, the anatomy of the use state here. So far so good. You have the value, you have the setter, the getter, and the setter. Okay, where now the set state setter is a function. Okay, your component rendered the first time because you pass 0 for that, and then you update the state when the user clicks on that, and your component's second render. And React still sees use state 0 for that. But because React remember that you set index to 1, it returns to that. Because what it's doing here is that React now, when we call this component, is now executing this. Okay, and all of your states are stored in a persistent place using a closure. Something that we're not going to talk about that, but this is now the mechanism that it uses to actually store that. I think the using is a mechanism for that. I prefer not to include that. This is more like an hypothesis, because well, this is now a feature in JavaScript of how you can now store data. But again, this is not a JavaScript course. Let's get into this. Okay, so what it's doing is that anytime it runs this function, it executes that and forget it. Remove that. I don't know. So the next time I'm going to run this function, now I got is this persistent state, this local. Okay. State is isolated and private. Exactly. States are per component. If you render the same component twice, each copy will have completely isolated state. Exactly. As you can see here. So we are showing is that two galleries, and now they're going to contain is this particular state or data. So why this is important? Unlike prop states, it's fully private to the components declared. Okay, use a state variable when a component needs to remember some information between renders. Is that it is? Because of it all, React is going to render this function, and when you need something to remember, okay, use an state for that. And how hooks are special functions that start with use. They let you hook into React feature like state. So they allow you to now is to remember this thing or hooks into that. Hooks might remind you of import. They need to be called unconditionally. Calling hooks, including use state, is only valid at the top level of component or another hooks. The use state hooks return a pair of value, the current state and the function to update it. You can have more than one state variable. Exactly. Internally, and state is private to the component. So why this is important? Fixed stock input. Fixed stocks form inputs. You got it this. And on submit, you're calling is this. Handle first name change. Okay. Okay, fixed stock input. As you can see, is this. You will need to say is that hey, This is more like a convention for this, by saying is, hey, this first name and set first name, it'll come from use state here, okay, but this needs to be imported by React. Import use state as a way to remember things, okay, from from React, okay. So now you can actually exactly, we need to actually set this. But this is how do we set this as it is, as a way to notify, hey, we want to update the value. You know, this is how we now tell React to re-render this component and remember this. Okay. Hey, I want you to remember is this data, this state for me. First name, and that kind of thing, right? Say, hey, you can say reset. But I think reset is not set to anyone. Handle reset. Exactly. Is to set here, set state to that. Alright. Reset, you got it. So the idea here is to now have the ability to describe how do we get here. Okay? And now when it comes to understand how React is rendering this, okay, how React is displaying elements on the screen, you must understand is what is doing behind React behind the scenes. So before your component are displayed on the screen, they must be rendered by React. Okay? Interesting. So before your components are displaying on the screen, they must be rendered by React. In other words, especially when you're defining is this memory or this persisting state, the components memory using the states. All right, it makes sense now to say good, because now, yeah, good, because now we have is good, because now we have is the how do you call it? Yeah, good, because now we exactly prefer to talk about that more deeper. Good, because now we have is the way of how can we remember states, remember data using the states, a component's memory, okay. And from that, it's like, okay, now we know how to use it and how to create our own custom hooks for that. And as a way to now understand how all of these elements are displaying on the screen, React, we must know, so they must be rendered by React. And rendering is the core aspect of the React, okay? And understanding this step in this process will help you to think about how your code executes and explain its behavior. Crucial, especially if you're going to perform or to diagnose performance issues. Okay, so you are now going to have these tools. You're now able to describe what's going on here. One, and second, you're also going to now, especially because we're looking at the performance aspect of React components and how to write this performance React component. Okay, so now what we're going to do is to understand now how React renders, and describing is the different phase that you get from the docs and then from the developer experience. Okay, so because render here is now the way of how now React show elements on the screen. We need to understand how that works. So understanding this step in this process, rendering o el pintado de React, okay, will help you to think about how your code execute and explain its behavior. So we're gonna see what rendering means in React, okay, when and why React renders a component, and the step involved in displaying a component on screen. So why renderings does not always produce a DOM updates. This is the core. This is the core of this. Because as you move on with other stuff, it's like this is now how you can well, take a look at more specific niche specific use case. You know, not to mention is escape the hatch. Okay, so for example, like this, synchronizing with effects. So what effects are? For example, like use effect, okay, and that kind of thing. And why this is not rendering here? Use ref, which is a specific component there. You say, hey, if you're playing, do this. So run that. If not, run this. And then return the video. Reference here. Loop plays inline. But if you say, hey, ref current is null, 0 there. Exactly. And how about using a use effect? You are going to run is this, because this is an event that happened is not in sync. Okay, you want to now run this yeah, you want to run this because here's going to be passed is the callback here. You want to run this now the first time as it is. So you're gonna hold this memory here, you're gonna remember this, okay, and then exactly it's playing, it's else, currently play, currently pause. So on the first time I want you to now run this. Wait, what? There you got it. There you got it. Will you not detect that? Unless you need is a callback here function. Okay, but we are okay. Okay, because it requires you to have this. It's plain here. But if you say it's plain, okay. Exactly. You need to pass that this as a way to detect that. Okay, and then we need to pass the is playing here. Exactly, as a way to now indicate that, hey, it's going to actually reproduce this. Calling this while rendering isn't allowed. In the current dot place, also this create. Mm-hmm. Exactly, it's because here what it's passing is this to this particular context. Mm-hmm. Mm-hmm. And that's quite interesting here. But again, the whole point of looking at this, okay, first is to add in the interactivity and how to understand now the React component model works. Okay, by looking is at, or particularly is that how now elements are rendered on React 1. So now you can understand how this process works and how it execute your code. So first we're going to look at what render means in React. Okay, and rendering means is exactly, and rendering mean is the calling your components, all right, but because it has 3 steps. Okay, first is the render. So this process works by having these 3 steps: render, exactly, it triggers and UN updates, and then it renders, which means that it's going to call is the, if this which we're gonna call, exactly, it has several steps. So this is how now React updates the UI, and that is you have this UI element here, okay, and you want to React somehow is to update that, okay. So there is a process that is the trigger, the trigger, render, and commit. So the trigger is the way how now React detect when there is a rendering, okay, when you need to display a UI element, and it can be at the end, initially at the root of this element when you're gonna pen all of this, or when the component state or the ancestors states updates. Okay, this is the 2 ways of how can that happen. So it's the initial render or re-render when the state updates. And when that happens, now renders mean is calling React functions. In other words, calling those functions, those JSX functions. Okay, calling those JSX functions makes a lot of sense. Okay, makes a lot of sense. Calling those functions. Okay, it's calling those functions. Okay, and it can be on initial rendering, so React will call the root component, or for subsequent render is that React will call the components function whose state triggers the rendering. And this is something important. The function component whose state triggers the rendering. And if that component contains other React components, it will now call those React components, and if those components contain more React components, and we'll call that and call that again. It's calling, not repainting. Okay, and that's very, very interesting. That's something interesting to have in mind. Rendering must always be a pure calculation. So sense input, sense output. Okay, it minds its own business. It should not change any objects or variable that exists before rendering. One order should not change anyone else's order. It should not change any objects or variable that exists before rendering. Otherwise, you can encounter confusing bugs and unpredictable behavior as your codebase grows in complexity. When developing in strict mode, React calls each component function twice, which can help surface mistakes caused by impure functions. So, but once now React renders that components by calling all of these React components recursively, all right. Now it is time to commit. Okay, and the commit phase, it can be at initial render. Okay, by adding is the append child and then putting all of the nodes it has creating on the screen, or for re-renders, which means that it's going to apply the minimal necessary done updates if there is a difference between rendering between different React components. So that's one of the reasons why you have to find a trade-off here, because you don't want your component to be too small, because otherwise you will have now performance issues, but as well you don't want your components big enough. You know, because otherwise you wanna, if that component state change, it will now cause to call all of these React components, and if any of those components are different, then it's going to apply the change. So again, this is one of the reasons why it's important to look and read at the documentation, take notes out of that, and understand this. Okay, all right. So once now the React apply the done change, now is when the browsers paint. So now is when the browser paints your elements. So, but again, this is quite crucial as a way to understand this. Okay. All right. Okay. Totally. Okay. React doesn't touch the done if the rendering result is the same as the last. So state as a snapshot. State variable might look like regular JavaScript variables here that you can read and write to. However, state behaves more like a snapshot. Okay. State behaves more like a snapshot. Setting it does not change the state variable you already have, but instead triggers a re-rendering. Okay, the idea is to look now at, so once we look at how can we add interactivity by seeing how we can respond to events, and then how now use a state, this component's memory, as a way to now pass states and to persist data when React evaluate or React components, all right? When React rendering our components, and we need to understand what the renderings works as a way to know how our code is evaluated. Okay, as a way how your code execute and explaining its behaviors. Okay, that React now follow this three stage, the trigger to detect is when an event happened. It can be initial, the initial render, okay? That's when React starting to trigger that, and or it can be when the components states change or any ancestor's component state updates. So if that happened, then you're going to now render your component, which is just calling the React component by evaluating all of your components. All right. And one of the great things of this state is that because in JavaScript, when you evaluate a function, it's gone. One time, you're gone. All right. So with this state, it allows us to persist the memory. It allows to remember data. Okay. So the rendering path or the rendering state is, all right, let me now take a look at the render, or take a look at which caused the rendering, and let me call, if this is the initial rendering, okay, let me now append all of these nodes to show the interface. Or if this caused a re-rendering, okay, this was caused by a re-rendering, React will call is the component states that change. React will call is the component states that perform the state updates. And then if that component contains other React components, it will call those functions, and if those functions, the output contains more React components, it will call that, so on, in a recursive way, okay, until there is no more React components. So this calling process is something that can cost you, okay, and is in there. Now that once React keep track of which component actually have that need to actually perform the state updates, is then now commit the change. It say, all right, now let me look in the case of the commits phase. All right, is that now let me if this is on the initial render, okay, then I'm going to apply all of this child now, or then I'm going to append childs to the down here, okay, if this is the initial render. If it's not, so let me now reapply is the necessary minimal down operation, as long as those React components are different, okay. So then I'm going to trigger is a re-rendering, a evaluation. So that's when you have to be careful here, because if we now take a look at that, the TLDR of that is that React is now the mechanism of React of looking at how this rendering component works is that first I'm going to take a look at, hey, who caused this trigger? Then, all right, let me now render it. Let me now call is the React components first, whether it's on the initial, if this is an initial render, or if this was caused by a component, re-render a component. If it is, well, now let me call is all of those. So if it is, the result of that component, if that contains React components, I'm going to run those React component functions. And if the output that I get from that contains more React component functions, I'm going to do that until there is no anyone. And then it's going to commit the change. And commit the change is that if this is the initial render, I'm going to append the child, which means I'm going to append childs to the DOM here. However, is this caused by a re-rendering? Then I'm going to apply is the minimal burn done update, but as long as those React components are different. Holy moly. Oh, okay. I don't know who actually sniffed this, because that requires a lot of engineering process and thinking process step by step. That's quite interesting. That's why quite wild. That's definitely wow. Yeah, it is. Yeah, it is. Oh, yeah, totally. That's wild. That's wild. Oh my God. Yeah, it is. That's wild. Okay. So now that we look at this and how we can think of state as snapshot, okay? How setting states triggers re-rendering, when and how state updates, why state does not update immediately after you set it, okay? Because it happens is when the renders ends, and how the event handler access a snapshot of a test. So setting state triggers re-renders, and when and how all state updates, why state does not update immediately after you set it. Interesting. So rendering takes a snapshot in time. Rendering means the React is calling your component, which is a function. The GSX you return from that function is like a snapshot of the UI in time. Okay? It is props, event handlers, and local variables were all calculated using its state at the time of the render. Unlike a photograph or a movie frame, the UI snapshot returns its interactivity. It includes logic like event handler that specify what happened in response to input. React updates the screen to match this snapshot and connects the event handlers. React updates the screen to match this snapshot and connects the event handler. As a result, pressing a button will trigger the click handler from your GSX. When React re-renders a component, React calls your function again. Your function returns a new GSX snapshot. React then updates the screen to match the snapshot your function returned. Like this. So this is now describing is when React re-renders a component, React calls your function again. Exactly. Hey, this is going to trigger a re-render. Okay, this is what caused by a state change. So what I'm gonna do here is to call the GSX function again. Okay, if your function returns a new GSX snapshot, React then update the screen to match the snapshot your function returned. React executing the form, exactly. React executing the function, calculating the snapshot, okay, and then updating the DOM. So you will tell React to update the state, so it will now update is the state and calculate the exactly. It update the state, and then it's gonna give you is React pass a snapshot of the state value, and React pass a snapshot of the state value into the components. Here's a little experiment to show how you how this works. In this example, you might see expected the clicking 3. So because it's now you tell to React, okay, you tell React to update the state. React update the state value here, and then React pass a snapshot to the state into value. So it's going to evaluate this. It's going to say, hey, here's the state, here's the state, here's the state, okay? And because at that moment number was 0, 0 plus 1 is 0 plus 1 is okay 1, 1 and 1. So it's supposed to give you is 1. Exactly. You know, hey, here's the state. Okay, this is now describing is the rendering process or state, how setting state trigger re-rendering. Okay, how setting the state trigger re-renderings. Okay, okay. So what you're doing here is saying, hey, React, you tell React to update the state. Hey, update the state, update the state, update the state, all of this. And then after React evaluate that, it say, all right, I'm going to update that. And that means that after React evaluate this entire function, GSX, it say, all right, now I'm going to update that state. And here is the snapshot of the state value into the component. So this is quite interesting. Setting state only changes it for the next render. During the first render, number was 0. This is why in that render on click handler, the value number is still 0. It was called like this because now it's evaluating this exactly. Hey, React prepared the change for number to 1 on the next render. Set this. React prepared the change the number to 1 to the next render, and that kind of thing. And if you say this, for example, 2, it will actually get only the last one. Again, this is JavaScript. It's evaluating one line after the another. Okay. You can also visualize this by mentally substituting the state variable with this. Okay. So if you want to pass states over time, well, that was funny, but try to guess what clicking this button will alert. Okay. And then it's rendering take a snapshot in time. When and how state updates. Why state does not update immediately after you use it, and how event handles that. Okay, here's the state, here's the state, here's the state that I'm updating, and then you got it. Okay, so number, set numbers, and use a state. Cool. Cool. So what it's doing here is now it's calling is a function here. And they say, hey, okay, state over time. And say, hey, now evaluate this. Hey, here's the state. Evaluate this. Here's the state. Once you get that state, he will return you a snapshot. A state as a snapshot. React passes a snapshot to the state value into that component. So React now passes snapshots of the state into the React components. It's like, hey, now this is not this value. This is now is state over time. So previously we looked at how the onClick, right? State over time. Okay. And here, how now this is being evaluated. So because number here is now set to 5, okay? So it's on the next rendering, it's gonna give you is the number. That's what happened. Because here you're telling is that, okay, state as snapshot. It's because here you're telling to the you're telling to this to the, oh my god, here's when you're telling to React, hey, I'm going to update the states, okay, and now React is okay, let me evaluate all of this. All right, I'm gonna update the state, and then it's gonna, after I evaluate this, okay, and after I evaluate this, exactly, And then after evaluate this, all right, here's the snapshot state for this component. And this is now when alert is 0 initially. Because on the next render, you're gonna get that. Exactly. Because here's now how you pass a snapshot as states as snapshot. Because this is now how you pass is how you tell to React how to update the states. Because that's the entire reason here. Okay. Setting it does not change the state variable you already have, but instead trigger a re-render. Exactly. So after we look at how now the rendering phase work, we look at how can we now setting a state as a snapshot, but it actually triggers a re-rendering, which means that after it passed through all of those phases, the trigger, it detects the state change. All right, now here's the state that I passed to the React. It evaluates the entire JavaScript function, okay, and then it's going to render the component, which means is that hey, this component that which state change returns a JSX that contains this component, okay, React component. If it is, let me now run those React components, execute the code, taking a snapshot of that state, okay, and then evaluate if that actually contains is a React component. If it is, I'm going to evaluate that until it is done, and then on the commit phase is when I'm going to actually if this was on the initial render, okay, here's all of this component. I'm going to append child to all of the down nodes. If not, then now I'm going to see which components cause the re-render, and then only update the down with the bare minimal updates, and then only going to update the down with the bare minimum stuff if those React components are different. Okay, and in this case, after the browser renders that, okay, yeah, after the browser renders that, okay, here's the state. Here's the state as a snapshot to this component, or to all of this component. So setting states only change it for the next render. And for the next render, it means for the next React function call. For the React next function call. Okay, state over time. So this will cause is now to set the number here right after that, right after the render. Okay, so you're not gonna have access to the number here as you expected. You'll have access is on the next render. Okay. What if you put a timer on an alert so it only fire after the component re-render? Will you say 0 or 5? Have a guess. Because this is how this component works. Number and on click is going to evaluate each one of them and say the alert here will be the alert here will be 0. Okay, so first thing first is evaluating this. Okay, in the next render you're gonna have this 5. Okay, and then he's evaluating this. Your passing is now is the number. Okay, effectively creating is a closure here. You're passing is the number, but the number here is 0, and that's what you're gonna throw after 3 seconds. 3. Here's the value, 0. Surprise! If you use the substitution method, you can see the snapshot of the state passed to the alert. Exactly. So the state stored in React may have changed by the time the alert runs, but it was scheduled using a snapshot of the test at the time the user interacted with it. A state variable value never changes within a render. A state variable value never changes within a render. Even if it is an event handler, code is asynchronous. Inside the React, okay. So a state variable values never change within a render. It's on the next render. Okay. State as a snapshot, the TLDR is just to describe is that states variables values change on the next render. It never changes within a render. So for example, here in this case, you have to state, okay, with your function here for on submit, handle submit. It's gonna call that when you push the button type submit. That's right. Where it's gonna call is this prevent default behavior. That's right. Alert you say message to. So in this particular case, whether the value of the hello you have at that moment, okay, you say what up at that moment, okay, at that state change, in this case at that state change, okay, then is what you're gonna have is that you say what up to Alice. Exactly. So React keep the state values fixed within one's render event handler. Okay. So React keep the state values fixed within one render's event handlers. Okay. So you can mentally substitute state in event handler similarly how you think about the rendering JSX. Event handlers created in the past have the state value, but if you want to read the latest state before a re-render, you'll want to use a state updater function. Coverage on the next section. Okay. If you want now to read the latest state before the render, okay. This is if you want to read is the next state. Oh my god. This is if you want to read now is This is if you want to read now because a state variable value never changed in the within the render. Okay, it will change this on the next render. So far so good. State as a snapshot. But if you want to now read a variable before rendering, okay, if you want to read a variable before rendering, or exactly, if you want to read the latest state before a re-render, you'll want to use a state updater function covering in the next page. Setting a state variable will queue another render, but sometimes you might want to perform multiple operations on the value before queuing to the next render. Exactly, you want this to read or perform some multiple operations on the value before the state change. You want to do several transformation. To do this, it helps you to understand how React batches states updated. This queuing a series of state updates is because now that you know how these snapshots, now that you know how state as a snapshot works, by understanding is that it will trigger a state change is on the next, so the state's value will be reflected is on the next render, not within this. Okay, and no matter how many state changes you pass, it will evaluate your React components. We're gonna get that state, update the state after you evaluate the React component. If you trigger a rendering, okay, and then gonna give you is this snapshot to the proper, and they give you the snapshot state to the proper components. So far so good, because this is the way of how now React works, especially when you want to set the state. So states values are set is on the next state values are set is on the next render. And if you want to work with handlers, okay, you can is pause that to actually trigger is the state. But what happens when you need to apply some operations to states before triggering an updates or before rendering, right? Before queuing the next render, before queuing is the next React calling functions, okay, and then commit. To do this, it helps you to understand how React batch states updates. When batching is how React use, okay, what batching is and how React uses process multiple state updates. How to apply several updates to the same state variable in a row. Okay. Yeah, what batching is and how React uses it to process multiple state updates. Yeah, what batching is and how React uses to process multiple states update. But again, this is if you want to perform multiple operations on the value state before queuing the next render. Okay, how to apply several updates on the same state variable in a row. React batch states update. Okay, when you want to actually apply several state change before updating and rendering. Okay. So React batch state update. You might expect that clicking +3 button will increment the counter 3 times because it calls set 9. But as you can see, however, it might recall from the previous sections that it's not that. Each render's values are fixed. Each render state's value are fixed. So the value of number inside of the first render's event handler is always 0. No matter how many times you call set number 1 here. But there is one other factor play here. React waits until all code in the event handler has run before processing your state update. So it now run all of this code before processing your state update. This is why re-render only happen after this set numbers call. This might remind you to a waiter taking orders at the restaurant. You're telling them, hey waiter, take it. Now I would like this and this and that, you know. A waiter doesn't run to the kitchen at the mention of your first dish. Instead, they let you finish your order. So you can think of this as an order here, especially when you have now batch in queuing a series of state updates. Hey, this is my order, React. All of these operations, set the color orange and here and that. Okay, batching here. Okay, and helps to understand how React batch states updates. Okay, so this might remind you of the waiter. That's right. This lets you update multiple state variables, even from multiple components. without triggering too many re-renderings. Exactly. But this also means that the UI won't be updated until after your event handler and any code in it completes and any code in it with this. This behavior, also known as batching, makes your React app much faster. It also avoid dealing with confusing half-finished re-renderings when where only some of the variables has been updated. React does not batch across multiple intentional event clicks. Each click is handled separately. Rest assured that React only does batching when it is generally safe to do. This ensures that, for example, if the first button click disable a form, the second click will not submit it again. So React does not batch across multiple intentional event-like clicks. Okay. But its batching is until all of the code in an event handler has run. Exactly. So it will wait all of the code in an event handler that has been run before processing your state update. But this is not for the event-like clicks. Okay. So updating the same state multiple times before the next render. It is an uncommon use case, but if you would like to update the same state variable multiple times before the next render, instead of passing the next state value like this, you can pass a function that calculates the next state based on the previous one in the queue. Okay, so this is now how you can batch and calculate the previous one. It is a way to tell React do something with the value state instead of just replacing it. Exactly. So here is now how you can work with the previous states and then do something about it. Interesting. So for example, this is an string. Hey. Okay, yeah. Hey, I want you to now say here, hey, say hey, hey, hello, were exactly, but it's batching all of those state changes. And then on the next render is when I'm going to update that. This is just a way to work with the previous state and do something about it. But it's rare. It's an uncommon use case. Okay. It is an uncommon use case. What happens if you update state after replacing it? In this case, because this will work on the next render, okay? The state values update in the next render, okay? So in theory, you're gonna run this. It'll have 5, okay? And then I think you are batching, because this is batching. This is now 5, okay? This is supposed to be 5, and then at least logically, and then the 5 you're gonna add someone, right? Exactly, because it's batching all of this. Here's what this event handler React helps to do. The number is 0, so set the 0 to 5, and React adds replay with 5 to its queue. And then set the number here in an updated function. You say now take the previous state, okay, of that, take the previous state values and apply this transformation and returns that. What happens if you replace state after updating? It's supposed to show you is 42. Exactly. It's supposed to show you 42. Like, hey, replace with that. This is all of these requests, all of your order here. This is how you tell React, hey, do this order. No, hey, I prefer to do this. No, you know what? I would like to do this. And they say, okay, I'm gonna take all of your order here, and okay, queuing a series of state updates, and then naming conventions like this. If you prefer move verbose common convention is to repeat the full variable state like this and recap. Fix a request counter like so. Pending completed, and here you're gonna call is this set pending await delay 3. What do you want me to do? You're working on a marketplace app that lets users submit multiple orders for an R item. At the same time, each time the user presses the button buy, the pending counter should increase by 1. The pending counter should increase by 1. Okay. After 3 seconds, the pending counter should decrease, and the completed counter should increase. Okay. So, I wait 3, and it's not working. Wait, what? Exactly. It's like at the same time, each time a user press a buy button, the pending counter should increase by 1. After 3 seconds, the pending counter should decrease, and the complete counter should increase. Exactly. After 3 seconds, the pending counter should increase, should decrease, and the set complete should increase. So what it's doing here is now is you're batching all of this state. So first you're saying, hey, set the pending plus 1, which is gonna do initially. I'll wait for this, okay, and then you're gonna set the pending minus 1. However, the pending counter does not behave as intended. When you press buy, it decreases to minus 1, which should not be possible. And if you click fast twice, both counter seems to behave unpredictable. Why does this happen? And fix both counter. It's like set pending 1, await delay 300, and then he say set pending 1 minus 1, and then set complete plus 1. Okay, this is the delay. Resolve this, because I already expect that. Set timeout, resolve this. Okay, a delay, there you got it. So we're getting is this. You're gonna pass the millisecond as well as this. What we are not able is to define this, or to pass that. So instead what we're gonna pass is that state to be on the next render. Exactly, when we hit buy, okay, it's set to minus 1 because for some reason it's not remembering that. Because for some reason it's not remembering that. For some reason, it's not remembering is that state. Set completed plus 1. And because now this is working asynchronously, we need to work with the previous state here. Okay, as a way to say, hey, okay, hey, do you know the, okay, do you have is the previous value? Okay, do you have the previous value? I want to get the previous value here and then update that. Okay, so batch this. Okay, and then once 3 milliseconds has passed, I want you to now get me is the previous value that you have and then decrease that. Similar to the complete here. I want you to now get the completed previous value and then increment that. Exactly, and then he's processing all of these previous states. Because if you don't pass this previous state, it's like you're putting is exactly, if you're not processing this previous state, if you're not passing the previous state, what happens is that this state, okay, if you're not passing this previous states, that's quite interesting. Holy moly. Yep. Or if you don't pass this previous states, then what you're doing is that, hey, you're doing is that, hey, depending, this is the state that I want to pass here, but then that same state, no, which is 0. Exactly. What you're doing is that you're working is with the previous state as a way to handle these async operations, as a way to now batching all of this operation, as a way to tell to React, hey, I want you to process this states here. Because otherwise, if you're setting this, you are now using is the current state, not the previous state. Oh my God. That you're using is the current state as a snapshot, not the previous state as a snapshot. And if you use the current state as a snapshot, that's what happened. That's exactly what happened. That's exactly what happened. It's telling you, hey, this current state is now 0 plus 1. After 3, then it is now 0 minus 1. Because I don't have any previous state. You know? And the complete is plus 1. Okay? And that's exactly what happened here. You know? It got that weird behavior. But because now we want us to work with the previous state by saying, hey, depending, okay, I want you to batch states here. I want you to batch state updates. Oh my God, exactly. Or queuing a series of state updates here, like it is. Queuing a series of state of queuing a series completed. Queuing a series of batch here. Hey, I want you to now, with the previous state that you have, because first you do this, okay? Give me the previous state, which is initially 0, and then now 0, we're gonna have is, you're gonna add that 1. We're going to await for that. This is interesting. You can put async await like this. So that's great, but not that great, especially if you're going to handle this in use effect. And then you say set pending here as it is. You say, okay, what is now the previous value of pending? Hey, because we are batching, okay, because we are now in queuing, we are queuing is series of state updates. Well, that is 1. Okay, 1 now will be is -1, which is 0. Good. And then the complete, which is initially 0, you're gonna pass and then add that 1. So no matter how many times you make this fast, then you're going to discount that. That's quite interesting. And implement the state queue yourself. Exactly, and then implement the self queue yourself. Base state. That's quite interesting. Updating object in the state. Okay. Okay. Again, this is queuing series of states. Update. As a way to work with the previous states here. Okay. But let's see if you want to work with that. Okay. And updating object in a state. This is called a mutation, and you don't want to do that. Treat any JavaScript object that you put in a state as read only. Exactly, you're going to create a new object. Create a new object and pass it to the state setting function. Because you're mutating the state and you don't want it. You want this to create a new state out of this. Local mutations is fine. Exactly, for local mutations. Copying object with a spread syntax. Exactly, copying object with the spread syntax as a way to now say, alright, updating object in a state. Updating a nested object. Person that outwork like that. Objects are not really nested. Write consists update logic with emer. As a way to say is like flattening it. But if you don't want to change your state structure, you might prefer a shortcut to nested thread. Emer is a popular library that lets you write using the convenient but mutating syntax and takes care of producing the copy for you. It doesn't overwrite the past state. This is if you want to updating object in a state, and the other is updating array in a state. Okay. All right. Okay. So far so good. Good. Yeah, completely. That's quite interesting. Totally. Reacting to input with state. Mm-hmm. Mm-hmm. And how declarative UI compares to imperative? Exactly. Identify your component's visual state. Determine what triggered those state changed. Represent the state in memory with use state. Remove any non-essential state variable. Choosing the state structure. Is that the group related state or this? Avoiding contradictions in states. Avoid redundant states. Take this form and it works, but you can find any redundant state in it. Don't mirror props in a state. Okay. Don't mirror props in a state. Yep. Alright. Don't mirror props in a state. Yep. Avoid deeply nested state. Yeah, totally. And recap, improving memory usage. To remove the deleted items and their children from the table objects to improve memory usage. This version does not that. It also uses IMER to make updating logic more concise. Update your logic here. Update your nested logic here. Fix a component that's not updated. Exactly, never. So avoid mirroring contradiction in state, avoid redundant state, avoid duplicating in state, avoid deeply nested. It's like instead use those per se. Avoid mirroring that. Because now fix a component that's not updated, because now props trigger a re-rendering. Interesting. Reacting to input with state. Exactly. Reacting to input with state. reacting to input with state. Using the state structure here. Sharing state between components. Sharing state between components. Preserving and resetting states. Extracting state logic into a reducer. And passing data deeply with context. Scaling out with reducer and context. Passing data deeply with context. Okay, that'll be all for this video. All right, and I think that's what quite very illustrative as a way to understand how all of these things actually works and how we can do that. And that'll be all for this video. Take care. Bye bye.